MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the experiment on operational amplifier application as integrator and differentiator. The aim of the experiment is to construct and test the performance of an integrator using IC MU-A741. To construct and test the performance of a differentiator using IC MU-A741. The design formulas and calculations for choosing the components for the experiment is shown here. Frequency value will be chosen by the designer for the operation. Here, the design frequency is 50 Hz for both integrator and differentiator op-amp. Assume the capacitor values and any one resistor value to design the other values in the circuit. The figure shows the circuit diagram of inverting differentiating op-amp and the output waveform. The output of differentiator op-amp is spike waveform when the input is given as square wave. The waveforms are plotted in the figure. The input for the circuit is given to any terminal, either the inverting terminal or non-inverting terminal. Based on the input given at the input terminal, the output will appear. Let us start the circuit connection based on the circuit diagram. The figure shows the circuit diagram of inverting integrator op-amp and the output waveform. The output of integrator op-amp is triangular waveform when the input is given as square wave. The waveforms are plotted in the figure. The input for the circuit is given to any terminal, either the inverting or non-inverting terminal. Based on the input given at the input terminal, the output will appear. Let us start the circuit connection based on the circuit diagram. The result of differentiator and integrator op-amp is noted here in terms of volts.
Good morning, dear students. Today I am going to show our operational amplifier that will be worked for integrator as well as a differentiator. The aim of the experiment is to show our operational amplifier MU-A741 IC that will be worked for the differentiator as well as an integrator. For this experiment, we need the components of signal generator. So this is the signal generator. This is the main power button to switch on the signal generator, and this is the on and off switch to exhibit the waveforms to the circuit board, and this is the monitor to display the waveform, and this is the sine wave, square wave, ramp wave, pulse wave, herb wave, and noises that will be used to generate the signal to the input for the circuit. DC power supply. This is the DC regulated dual power supply. So this is the main switch on button to switch on this particular system. So we have two main parts here. One is this part and another one is this part. So I'm going to explain what is this part. So this is the voltage tuner and this is the current set tuner. So in the voltage tuner we have two main categories. One is coarse tune and one is a fine tune. If you want to tune your voltage to maximum level in maximum numbers, that will be used by coarse tuner. If you want to tune the voltage that in the minimum level, that will be choose with a fine tuner terminal. So if you want to set your current, that will be based upon the application, so you can set by using this current set terminal. So in our circuit we always keep this as a maximum current, and we have two main terminals. One is positive terminal and another is a negative terminal. So positive terminal is indicated by a red color and negative terminal that will be indicated by a black color. So this provides positive and negative voltage to the circuit, and the same operations what happens in this system that will be happen with this part also. And this is the ground connection. Normally we are used to this terminal in a very large applications. This is the display that will be used to display the values of voltage and current that will be generated to the system. Oscilloscope. This is the digital oscilloscope that will be used to measure the output. So in this device, this is the switch on button, so to turn on this system, and we have main two terminals. These are the one terminal and these are the another terminal. So we call this as channel number 1 and the channel number 2 that will be used to see the output. Okay, these are all the tuners to adjust the amplitude and frequency of the signal. Circuit board. So this is the circuit board or breadboard. This is used to connect our entire circuit. Okay, this is the series connection till this large gap, and again this is the series connection. So this is the series connection in x-axis, and this is the series connection in y-axis. Till this division that will be counted to 5, till that it is a series connection. After that this is one connection. MUA741 IC. This is IC MUA741. This IC contains 8 pin. Okay, that will be start with the pin number of this notch. This is the notch that will be indicates the pin number 1. Okay, this is pin number 1, 2, 3, 4, 5, 6, 7, 8. This is the 8 pin IC MUA741. Resistors. For this experiment I am going to use these two resistors. One is 10 kilo ohm resistor and another is 100 kilo ohm resistor. Capacitor, and the capacitor 0.1 microfarad. Connecting wires. These are all the connecting wires to connect the circuit and probes. This is the patch cards that will be used to connect the input and output devices to the circuit. Now let us start the circuit connections based upon the circuit diagram. Now I am going to show this how this operational amplifier that will work for an integrator. Now you take the MUA741 IC and place that IC into this circuit board like this. I connected the MUA741 IC to the circuit board. So this is pin number 1, 2, 3, 4, 5, 6, 7, 8. So we will take a 10 kilo ohm resistor that will be connected to pin number 2 to some other point in the circuit board, because this resistor I need to connect in between the pin number 2 and the pin number 2 to supply signal generator. So that I am connecting this pin to somewhere in the circuit board. Next I am going to connect the 10 kilo ohm resistor, 100 kilo ohm resistor to pin number 2 to pin number 6. I am going to connect. This is the pin number 6. 4, this is 5, 6. This is pin number 6. I am connecting somewhere here. Next I am going to connect this capacitor in the same way to pin number 2 to pin number 6. Now I am going to take the wire to connect the DC regulated power supply to pin number 7. So this is pin number 4, 5, 6 and this is 7. This is 5, 6, 7. This is 7 pin number. I am connecting this wire to here. You see the wire that will be connected to pin number 7. The same way I am going to connect this wire black that will be connected to ground. I made the ground somewhere here. I made this as a ground. You see, this is ground connection. Now I am taking another wire. I will connect the positive of this terminal to ground. So this is the ground connection. I am connecting to the ground. I am taking another wire. I connected this wire to pin number 4. This is pin number 4. I am connecting this terminal to pin number 4. Next I am going to take this probe to connect the signal generator. I connect the probe to signal generator. So positive of this terminal is connected to positive terminal is connected to this resistor. Series line I am connecting to this resistor. The negative of this wire that will be connected to ground. Next I am taking the two probes to connect the input and output. This probe I connected to port number 1 or port number 2, any port you can connect. That is port number 2 I connected. So this is will be connected to the port number 1. The port 1 of this wire that will be used for to see input connection. So I am going to connect this wire to see the input. Connected to the input terminal like this. The negative it will be connected to the negative of the wire. Now this is the terminal number 2. This terminal number 2 wire that will be connected to see the output, so that I am connecting this positive terminal of the wire to pin number 6. You see, this is pin number 6. To see the output we are connecting here. See here, that will be connected to pin number 6. Next I am going to connect this wire to the ground. So this is the ground connection. I am going to connect this wire to here. See here, that will be connected to ground. Now the circuit connection will be over. Now you switch on the system, signal generator, and switch on the DC regulated power supply, and switch on the oscilloscope. Now you set the DC regulated power supply to 12 volt. And this also you set to some 12 volt. So you can put mode 1. Now you can get the output of the integrator. So now our operational amplifier, so that will be gives an output of integrator. Hence the operational amplifier is working as the integrator circuit. Now you switch on the system, signal generator, DC regulated power supply, and the oscilloscope. You set this voltage to 12 volt, and this also need to set to 12 volt. Both are set to 12 volt. You put this as a square wave because the input for the circuit is square wave. So next you turn on the mode. Should be hertz. Offset you set it to 0 millivolt. Now we completed the experiment of integrator. So we already seen how operational amplifier that will work for an integrator. Now in the basis of same way we are going to demonstrate how my operational amplifier will work for differentiator. Based upon the circuit diagram, I am going to connect the circuit. Now I am going to start the circuit connection based upon the circuit diagram. First I am taking this circuit board. So I place this MU741 IC in the circuit board. I place the IC. Now you take, I want to connect this 3.3 kilo ohm resistor to pin number 2 to somewhere in the circuit board. This is pin number 2. I connected it somewhere in the circuit board. Next I am taking 33 kilo ohm that will be connected to pin number 2 to 6. This is pin number 2 and this is somewhere in pin number 6 here. 5, 6. I connected this to 6. Okay, I slightly bended it. Next I am going to connect the capacitor that will be connected to 3.3 to 0.1 microfarad. This is a 0.1 microfarad that is connected to the external resistor to somewhere in the circuit board, because this is need to connect to the power supply. See, it will be connected with a resistor and to the terminal 2. So now I am going to connect the wire, the positive, the DC power supply is to pin number 7. 1, 2, 3, 4, 5, 6, 7 here, connected to here. See, this is a 7, I am connected. So next I am going to connect the negative this wire to ground. I made ground somewhere here. Next I am going to connect the positive of this terminal to the ground. So this is the ground connected here. This is the ground connection. Next, the same way I connect this terminal negative to pin number 4. This is pin number 4. This is pin number 4. You see, that will be connected. The same way I take this probe to connect the signal generator. Signal generator one wire, I will connect it to positive, the wire that will be connected to this one input, and I am taking small wire to connect the pin number 3 to ground. This is 1, 2, 3, 3 to ground. And the negative of this generator that will be connected to ground. Now I am going to connect the oscilloscope with 2 wires. I am going to connect the first wire to see the input to the port 1, and I am connected the positive of the wire to positive of the signal generator. Positive of the signal generator, and negative terminal that will be connected to negative of the signal generator. Now I'm going to connect the wire 2 to see the output to the terminal 2. The positive of this terminal is the positive of the terminal that will be connected to pin number 6. This is pin number 6. You see, this is pin number 6. I'm going to connect this connected to pin number 6. The negative that will be connected to ground by using a wire I connected that to, this is the ground, connected to ground. So this is the positive terminal that will be connected to pin number 6 to see the output. This is the negative terminal that will be connected to ground. This is the ground connection. This completes the circuit connection. Now I'm going to switch on the signal generator. Now I'm going to switch on the signal generator, DC regulated power supply, and the oscilloscope. Now you set this to 12 volt first. Saturation voltage will be 12 volt for the operational amplifier MUA741. You set it to 12 volt. This also you need to set to 12 volt. Both will be set to 12 volt. Now you see here, so if it is a linear waveform, you don't worry. So you put that into a square wave signal and you adjust the frequency to 50 hertz and the voltage is 1 volt peak to peak. You adjust. So then you switch on the output terminal to 1. Now you see this is the output of a differential amplifier. Now we can conclude our MUA741 IC that will generate the integrated waveform as well as a differentiated waveform. So it is one of the applications of the MUA741 IC. So our aim of the experiment is we can use the operational amplifier MUA741 as a differentiator and integrator. So this completes the experiment of differentiator and integrator.
At MSR UAS, we spark your imagination unlike any other.